Hello children. In this video we start with the problems on differential calculus. First we see the problems on limits, continuity and differentiability. The first problem, limit extends to 0, x divided by, so square root of 4 minus x minus square root of 4 plus x. Now definitely as x approaches to 0, the value 0 by, it is in the form of 0 by 0. Now remember there is one formula, square root of a plus x minus square root of a minus x divided by x as a limit x approaches to 0, and that is nothing but 1 by root a. Now this is in the reverse order, taken minus common, this is same as this one. I can also write down this one as a 1 divided by. So it is a square root of 4 plus x minus square root of 4 minus x divided by x. And that is equals to 1 divided by minus 1 by root 4. And therefore the answer is equals to minus 2. So answer for the problem is equals to minus 2b. Coming to the next one, limit extends to minus 1, x to the power of 9 minus plus 1 by x cube plus 1. X power 9 plus 1 divided by x cube plus 1. Substituting x is minus 1 means this will be in the form of 0 by 0. Whenever you find a 0 by 0 form, you can go for separately differentiation method. Numerator, even you find the derivative 9x power 8 divided by 3x square. And thereby x is equals to minus 1. When you substitute, you will be getting 9 by 3. So the answer is equals to 3. The answer is 3. Coming to next one, limit extends to 3, 1 by x minus 2 plus 1 by x plus 3. Limit extends to 3, so 1 divided by x minus 2 plus 1 by x plus 3. Why can't you directly substitute here? It is a finite value, get it, 3 minus 1, 1 plus 1 by 6 is equals to 7 by 6. There is no much manipulation, it is a direct answer, it is 7 by 6. Coming to the next fourth one, limit extends to minus 1, x cube plus 6x square plus 12x plus 7. So x cube plus 6x square plus 12x plus 7 divided by x plus 1. Yes, as extends to minus 1. But as extends to minus 1, the summation of these two, this will be minus 1 minus 13 plus 13 is equal to 0. So this is in the form of 0 by 0. Why can't you apply derivative method? It is numerator separate derivative with respect to x, 3x square plus 12x plus 12 divided by 1. Substitute x is equals to minus 1. And then thereby you will be getting 3 minus 12 plus 12. The answer is equals to 3. So the answer is 3. Coming to next one. Limit extends to 3, 1 divided by x minus 3 plus 9x by 27 minus x cube. So 1 divided by x minus 3 plus 9x divided by x cube minus 27. You cannot directly substitute x equals to 3. Okay, as x tends to 3, you need to find out the value. The factorization of x cube minus 27, a cube minus b cube formula. So when you apply and simplifying, I say that x square plus 3x plus 9. I hope it is supposed to be minus here. Yes, it is supposed to be minus here. So plus 9 and minus 9x divided by x cube minus 27. And that on simplification gives us x square and minus 6x plus 9 divided by x minus 3 multiplied by x square plus 3x plus 9. The numerator is x minus 3 whole square divided by x minus 3 multiplied by x square plus 3x plus 9. As x tends to 3, 1 gets cancelled and the numerator is 0. 0 by something is equals to 0. So the answer for the problem is equals to 0. Coming to sixth one. 2x square minus 5x plus 2 by x square minus 3x plus 2. x tends to 2x square minus 5x plus 2 divided by x square minus 3x plus 2. Limit x tends to 2. Clearly you could see that. I hope you'll be getting 4 2s are 8 plus 2 10 10. Okay, 0 by 0 form. Once it is 0 by 0 form, you can proceed by L'Hospital rule, the derivative method here. You will be getting 4x minus 5 divided by 2x minus 3. Now if you substitute x is equals to 2, there we'll be getting 8 minus 5, 3 divided by 4 minus 3, 1. So answer is equals to 3. Coming to 7th one. And this is in the form of like x to the power of n minus a power n by x power m minus a power m. Limit x tends to a, limit extending to 2, x to the power of 5 root x minus 32 root 2 divided by, yes, x cube root x minus 8 root 2. This simply, I say that there is a one formula, x power m minus a to the power of m divided by x power n minus a power n. Limit extends to a is equals to, it is m by n multiplied by a to the power of m minus n. You can use that particular concept where m is equals to x to the power of 5 plus half. So therefore, this is x to the power of 5 plus half means it is 11 by 2 minus 2 power 11 by 2. And this is 3 plus half, x to the power of 7 by 2 minus a power 2 power 7 by 2. So therefore, the answer for this problem, m by n. So 11 by 2 divided by 7 by 2 multiplied by 2 to the power of 11 by 2 minus 7 by 2. And that is equals to 11 by 7 times 2 power 4 by 2 square. That is 44 divided by 7 is answer. So therefore 44 divided by 7. 44 by 7. Let's proceed to the next one. Square root of a plus x plus minus root of a minus x. As I told you, the first problem itself, the answer is equals to 1 by root a. It is a direct formula. Remember, this is a formula. Of course, you can rationalize, you can simplify. As I told you, the first problem, it is similar to that. Coming to the next 9th one. X tends to 1, x plus 2 divided by x square minus 5x plus 4 plus 3. X plus 2 divided by, it is x plus 2 divided by, I think you can factorize this one as x plus x minus 1 into x plus x minus 1 into x minus 4 plus x minus 4 divided by, it is a thrice x minus 1 x minus 2, 3 times of x minus 1 into x minus 2. So if you take up LCM of this, 3 times of x minus 1 multiplied by x minus 4 into x minus 2, you'll be getting x square minus 4 multiplied by 3 times plus x minus 4 taken whole square. And that is equals to 3x square minus 12 plus x square minus 8x plus 16 divided by 3 times x minus 1 multiplied by x minus 4 x minus 2. 3x square, that simplifies it as a 4x square minus 8x and plus 4. I hope this is nothing but 4 times of x minus 1 whole square. And 1 x minus 1 gets cancelled, and by substituting x is equals to 1, denominator is not 0, numerator is 0, 0 by something which is equals to 0. So the answer is equals to, for this problem, is 0, the first one. Coming to the next one. A power x minus x power a. So a power x minus x to the power of a divided by x power x minus x power x minus a power a, limit as x tends to a is equals to minus 1. Equals to minus 1. So what will be the value of a in this case if the limit value minus 1? I think you can go for simplifying this one as x tends to a. Yes. And when I substitute x equals a, the limit value, isn't it in the form of 0 by 0? Therefore, I can proceed by the derivative method. A power x derivative is nothing but a power x log a minus x to the power of a derivative a x to the power of a minus 1, and divided by x power x derivative is x power x multiplied by log x plus 1 minus constant derivative is equal to 0. As extending to a, that is equals to minus 1. Let me substitute. You'll be getting a to the power of, you'll be getting here a power a power a. A power a taken common, it is log a minus 1 divided by a power a multiplied by log a plus 1. And therefore gets cancelled is equals to minus 1. Clearly you could see that E is equal, A must be is equals to E, because log E is equals to 1. Log E is equals to 1, and thereby will be getting 1 minus 1. I think log A is equals to 1 would satisfy the result. 0 minus 1 by 0 plus 1. So because log 1 is equals to 0. Yeah, it is nothing but 0 minus 1 by 0 plus 1. So the result is equals to minus 1. So therefore A answer A is equals to plus 1. A is equals to 1, clearly satisfying the result. Coming to the next one, sine 2 theta, sine 3 theta. Yeah, remember the technique that in case of a sine and a tan, sine inverse and tan inverse functions can be replaced by the corresponding angles as theta tends to 0. So I can as well write the sine 2 theta is nothing but 2 theta itself. 3 theta can be written as 3 theta divided by, so 3 theta, 4 theta. 3 theta, 4 theta, theta tends to 0. Simplifying, you'll be getting 2 into 3 divided by 3 multiplied by 4. So you'll be getting answer 1 by 2. So answer is equal to D. Coming to 12th one. Here, numerator is sum to first natural number sigma n plus 2, n plus 3. So sigma n divided by n plus 2 into n plus 3 as n tends to infinity. Keep in mind one formula. This is nothing but sigma n to the power of p divided by n to the power of p divided by n to the power of p plus 1. So then the answer for this problem is 1 divided by p plus 1 as n tends to infinity. So as I say that this can be written as sigma n divided by n square will become 1 by 2 multiply n square. Why don't you take n common from each of the term? 1 plus 2 by n multiply by 1 plus 3 by n. As n tends to infinity, 1 by n tends to 0. So clearly you can see that these two gets cancelled. This is equals to 1 by 2 divided by 1 plus 0, 1 plus 0, 1. So the answer is equals to 1 by 2. The answer is C. Coming to this one, x tends to, so clearly you can see that 0 by 0 form. Sine pi x by 2 divided by x minus 1. 2x minus 1, sorry. X tends to pi by 2 when you substitute. X tends to pi by 2 or 1? Yeah, x tends to 2, sorry. As x tends to 2, when I substitute, you'll be getting sine pi by 2, 1 divided by 4 minus 1. X tends to 2 when you substitute sine pi 0. Yes, sine pi 0, 0, 4 minus 1. So clearly you could see that sine pi value, sine pi divided by 4 minus 3, answer is equals to 0. Direct substituting it. 14th one. As I told you, when sine and tan you can replace by corresponding angles. This can be replaced as 3 tan x, nothing but 3x, minus 8x divided by 3x minus 8x divided by 3x plus 2x. 3x plus 2x. 3 minus 8 minus 5x divided by 5x. Cancellation gives us answer minus 1. So the answer is equals to minus 1. Coming to 15th one. Sin square x minus sin square a by x square minus a square. Sin square x minus sin square a divided by x square minus a square. So why didn't you just apply the formula, trigonometric formula? This is nothing but sin x plus a multiplied by sin x minus a. Divided by, when you factorize the denominator, you will be getting x plus a multiplied by x minus a. Obviously, sin theta by theta, theta tends to 0 as extending to a, this will be 1. And this will be extending to a, sin 2a divided by, yes, this is nothing but sin 2a divided by 2a. Clearly, sin 2a can be written as 2 sin a cos a divided by 2a. 2 gets cancelled, sin a cos a divided by a. That is the answer. 16th one. Square root 2 cos theta minus sin theta divided by 4 theta minus pi. 4 theta minus pi. So when you substitute theta is equals to pi by 4, root 2 minus cos theta minus sin theta divided by 4 theta minus pi. 4 theta minus pi taken whole square. Okay. Now theta tends to pi by 4. I hope you'll be getting 1 by root 2, 1 by root 2, root 2 minus root 2, 0 by 0 form. And thereby you can apply the derivative method, and thereby you get it root 2 derivative 0, and it is sin theta minus cos theta divided by 2 times 4 theta minus pi multiplied by 4 theta derivative 4. Again 0 by 0 form. So again it is 0 by 0 form. I can apply derivative technique, thereby I'll be getting cos theta plus sin theta divided by 4 theta minus pi derivative is 4. So 2 multiplied by 4 multiplied by 4. And therefore theta tends to pi by 4 implies root 2 divided by 2 into 16. That is equals to. So therefore the answer is equals to 1 divided by 16 root 2. So therefore 1 divided by 16 times of root 2. B. Coming to 17th one. Here 1 minus cos 5x by 1 minus cos 8x. 5x divided by 1 minus cos 8x, x approaches to 0. We apply one formula here. 1 minus cos ax divided by x square, limit as extending to 0 is nothing but a square by 2. We use the concept of this one. Therefore, I divide this number by x square divided by this number by x square. So clearly, we could see the answer is equals to 25 by 2 divided by 64 by 2. So the answer is 25 by 64. So 25 by 64, the answer is A. Coming to the next 18th one. Limit extending to infinity x plus 7 by x plus 1. Limit extending to infinity x plus 7 divided by x plus 1 to the power of x plus 4. X plus 4. Whenever you find the limit value extends infinity, x plus a divided by x plus b to the power of x plus c, directly you can write down the answer as e to the power of a minus b. So using this formula, I say that the answer for this problem is nothing but 7 minus 1 is e power 7 minus 1 e power 6. So answer is e power 6. Coming to 19th one. In the same lines, there in the previous problem it is extends to infinity. Here in the sense extends to 0. That's it. It is similar formula for this one. So therefore you can apply e to the power of 7 minus 2 e power 5. So the answer is supposed to be e power 5. Yes, correct. E power 5. So you say that 1 plus, yes, so 1 plus 7x square divided by 1 plus 2x square to the power of 1 by x square. Therefore, e power 7 minus 2. Therefore, answer is equals to e power 5. Coming to the next one. Limit extending to pi by 4. Yeah, tan pi by 4 will become actually 2 minus 1, 1. 1 to the power of infinity. 2 minus 1, 1. Yeah, 2 minus x. So, but logarithm pi by 4, log tan pi by 4, log 1. Log 1 is 0, 1 power 0. Yes, of course, 1 power 0 is 1. So, therefore, 2 minus tan x to the power of logarithm of tan x as extending to pi by 4. This value is 1 power 0, nothing but 1 itself. So, the answer is equals to 1. Coming to now, this is also a direct formula. It is 1 plus ax to the power of b by x. 1 plus ax to the power of b by x. This can be written as 1 plus ax to the power of 1 divided by ax taken whole to the power of ab. Therefore, this is nothing but e as extending to 0. This is e to the power of ab. So, the answer is equals to e power ab. So, the first option. Coming to the next one, 22nd, a similar problem, we have done it already. As I said, it is a sigma n divided by n square. Here, we have a sigma n cube. So, therefore, it is a sigma n cube divided by n square multiplied by n plus 2 into 2n plus 3. n plus 2 multiplied by 2n plus 3 as n tends to infinity. This we need to evaluate the limit value. Why not you simplify this problem as like this? Sigma n cube, because power is 3 divided by n power 4 multiply n power 4 divided by, from here n taken common, n power 4 multiply by 1 plus 2 by n multiply by 2 plus 3 by n. So that these two gets cancelled. As n tends to infinity, this answer is equals to 1 by 4 divided by, it is 1 plus 0 multiplied by 2 plus 0. So that is equals to 1 divided by 8 is the required answer. So the answer is equals to C. Coming to the next one, n to the power of p sine square of n factorial by n plus 1. But observe, p lies between 0, 1, means p is a fractional value. So n to the power of a fraction multiply by sine n square n factorial divided by n plus 1 as n tends to infinity. Limit n tends to infinity. Remember one important case, as p lies between 0, 1 implies n to the power of p tends to 0 as n tends to infinity. Okay, as n tends to infinity, power value. And also, denominator tends to infinity. So something 0 by infinity model, therefore the answer is equals to 0, because the sine square n factorial is a finite number. So a finite value. So the answer is equals to 0. Coming to limit n extends to infinity, square root of x plus root x minus root x. Square root of x plus root x minus root x, limit extends to infinity. Let me simplify this one by rationalizing it. This can be rationalized as limit extends to infinity, x plus root x minus x divided by square root of x plus root x plus root x. I think these two gets cancelled, and now taken common one root x extends to infinity, root x by root x common when you take up square root of 1 plus, so 1 by root x by root x, I hope we'll be getting x, take 1 by root x plus 1. As x tends to infinity, 1 by infinity goes to 0. These two gets cancelled. That is equals to 1 divided by root of 1 plus 0, 1 plus 1. So the answer is equals to 1 by 2. The answer is 1 by 2. Coming to the next one. 1 minus 4 by x minus 1 to the power of 3x minus 1. So 1 minus 4 divided by x minus 1 to the power of 3x minus 1, and the limit extends to infinity. Of course, x tends to infinity is the same as x minus 1 also tends to infinity. X minus 1, 3 times of x minus 1 plus 4. Yes, this can also be written as 1 plus minus 4 divided by capital X to the power of 3 times x minus 1. This can be similar way, can be written as 3 times of x minus 1, minus 3 plus 4. Yes, of course, this is a 3x plus 4, minus 3, I hope minus 3 minus 2 plus 2. Yes. So therefore, we'll be getting it is a 3x plus 2. So obviously, this is x, limit extending to, yes, now x approaching to infinity. This is nothing but e to the power of 3 multiplied by minus 4. 3 into minus 4, the answer is e power minus 12. So answer is B. Coming to the next one, limit extends to infinity square root. I hope we can just directly rationalize this one. So under root of a square x square plus bx plus c minus ax. Yes, of course. So limit extending to infinity. If you rationalize this one, it is limit extending to infinity. It is a square x square plus bx plus c minus a square x square divided by root over a square x square plus bx plus c plus ax. Of course, these two gets cancelled. Why don't you take x square common in the denominator? See, actually, this is of degree 1 and the denominator also degree 1. So the coefficient of highest powers of x is nothing but answer, actually. So it is bx. X multiplied by b plus c by x divided by x multiplied by under root of a square plus b by x plus c by x square plus a. And of course, 1 by x approaches to 0. So the answer is equals to b divided by, of course, b plus 0 divided by root a square. I hope you'll be getting a plus a. Therefore, b divided by 2a. So the answer is equals to b divided by 2a. Yes. Coming to 27th one. 27. F of x is equals to x minus sine x divided by let's see that limit f of x extends to infinity. So limit extends to infinity under root x minus sine x divided by x plus cos square x. So why didn't you take a common value here, numerator, denominator, x into 1 minus 1 by x sine x divided by x into 1 plus 1 by x cos square x. Here, clearly see that x gets cancelled. As x tends to infinity, 1 by x goes to 0. 0 multiply a finite value will be 0. So therefore, 1 minus 0 divided by 1 plus 0 under root, that is equals to 1 is the answer. 1 minus 0 by 1 plus 0. The answer is equals to 1. Clear? Right. So the answer is 1. Coming to the next one. Limit n tends to infinity 0.2 to the power of. So 0.2 to the power of logarithm to the base 5. 1 plus. First of all, let me evaluate 1 by 4, 1 by 8, plus 1 by 8, plus 1 by 16, and so on up to infinity. Isn't it? This is infinite up to n terms. up to n terms. As n tends to infinity, this is nothing but infinite series. And therefore, a by 1 minus r. Each time you are multiplying 1 by 2, 1 by 2. A divided by 1 minus r. R is equals to 1 by 2. That is nothing but half. So, you'll be getting 1 by 4 divided by half. That is equals to 1 by 2. So, the result is equals to 0.2 to the power of logarithm of. So, half means nothing but the 0.5 to the base 0.5. So, therefore, half and root 5 to the base root 5, limit n tends to infinity, the value of this one. So, clearly you could see that this one can be simplified, and 2 by 10, 2 divided by 10 is nothing but 1 by 5. 1 by 5 to the power of 1 by 2 logarithm of half to the base of 5. Clearly, because this is a half, I hope it is nothing but half to the divided by half. 1 by half of it, and that is equals to 5 power minus 1 time of logarithm of 1 by 2 whole square to the power 5. And as the bases are same, this minus 1 taken to the power half to the power of minus 2. I hope answer is equals to plus 4. Answer for the problem is equals to plus 4. Coming to next one. Limit extends to infinity. We have one formula here. 227 8. 227 and 1 by x to the power of 8 divided by 3 whole power x extending to infinity. So clearly you could see that this is nothing but whenever you find of the problem of the type a power 1 by x, b power 1 by x, c power 1 by x divided by 3 whole power x as extends to infinity, the answer is nothing but cube root of abc. So here the answer is equals to cube root of 2 into 27 into 8. 2 into 27 into 8. This cube root and cube root. Of course, 2 into 3, 6. 6 multiplied by cube root of 2. So answer is equal to 6 multiplied by cube root to 2. 6 multiplied by cube root 2 is the required answer. So the answer is D. Coming to next one. 1 plus tan x by 1 plus sin x to the power of this one. It is similar to the exponential form as I told you the formula 1 plus x by 1 plus sin x. Of course, these two are same. 1 plus tan x by 1 plus sin x. E power 1 minus 1. Yes, it is 1 plus x by 1 plus x to the power of 1 by x. X extends to 0. So e power 1 minus 1. Clearly, that is e power 0. So therefore, answer is equals to 1. So the answer is supposed to be 1. See. Coming to the next one. Yes, from here we see the continuity and differentiability problems also. 31. Let's take up the problem here. 1 plus x, we know as x tends to infinity, 1 plus x to the power of 1 by x. Limit extends to, 0. Limit extends to 0, 1 plus x to the power of 1 by x is equals e. But e is nothing but the value of the function at 0. So therefore, it is continuous at point x is equals 0. Yes, so therefore, it is the function is continuous. At x equals 0, the function value is equals e. So the limit value is also e by the formula. So the answer is the function is continuous at x equals to 0. Coming to the next one. Sin 2x by x extending to 0 is equals to k. Function is continuous means the limit of the function equals to value of the function at x equals 0. See, continuous at x equals 0 means f0. That is equals to k. And that is nothing but limit extends to 0. It is sin 2x by x. Sin 2x by x. As I told you that one, sin 2x by x can be replaced by 2. So the answer is nothing but k is equals to 2x by 2. X cancel be getting 2. Okay, so the answer is equals to 2. Coming to 33. modulus x plus modulus of x minus 1. Modulus x plus modulus of x minus 1. If I consider, yes, f of x is equals to modulus x plus modulus of x minus 1. Of course, it is continuous at 0 and x equals to, of course, we need to check at the point 0 and 1 the continuity of the function. When I take up the values around 0, 1, yeah, modulus x is minus x plus x minus 1, plus 1 minus x. Yes, this will become 1 minus x because it is less than 0. So that this is minus x, 1 minus x. The result of this one is 1 minus 2x. Between 0, 1, this is x plus 1 minus x. The result is 1. The function value f is equals this one, and this is f is equals this one. And after 1, this is plus x minus 1. So f is equals to 2x minus 1. So the function is equals to 1 minus 2x when x is less than 0. And is 1 when x lies between 0 and 1. And is 2x minus 1 at x is greater than or equal to 1. So clearly you can see that f0 minus is equals to 1 and is same as f0 plus. At the same time, f of 1 minus is 1 and 2 minus 1, and that is equals to f of 1 plus. So it is a continuous at point 0 and at point 1. So the answer for the problem is continuous as well as at x equals to 0 and at x equals to 1. Coming to the next one, of course the same limit continuation. LCM is same. The numerator is sigma n. So therefore, it is sigma n divided by 1 minus n square. It is limit n tends to infinity. As I told you, this can be written as 1 sigma n divided by n square multiplied by n square divided by n square taken common 1 by n square minus 1. So that these two gets cancelled. As n tends to infinity, the answer for this one is 1 by 2 divided by 0 minus 1. So the result of the answer is equals to, result of the problem is minus half. Answer is equals to minus half. Coming to the next one, 35. Sine 5x divided by x square plus 2x when x is not 0, k plus half. He said the function is continuous, means the value is equals to limit of the function. That means the value is k plus half. That should be is equals to limit extending to 0, sine 5x divided by x square plus 2x. Sine 5x by x square plus 2x. So clearly you could see that this is in the form of, I hope you can replace 5x with the 5 and you can simplify. Okay, k plus half is equals to limit extending to 0, 5x divided by x multiplied by x plus 2. Yes, x cancel, x equals to 0 when you substitute. K plus 1 by 2 is equals to 5 by 2. Therefore, k is equals to 4 by 2. Answer is equals to plus 2. Answer is plus 2. Coming to the next one, limit extends to infinity. I hope this answer is already a repeated problem. So we had already half answer. Coming to 37, let f dash of x be continuous at x equals to 0 and double derivative f double dash of 0 is equal to 4, then the value of the function is how much? Well, if the limit is limit extending to 0, limit extends to 0, 2 times f of x minus 3 times 2 f of x minus 3 times f of 2x plus f of 4x and divided by x square. Divided by x square. Of course, when I substitute x is equals to 0 and f double dash of 0 is equals to 4. Let's see, and f dash is continuous function. Substituting, you will be getting, x equals to 0, 2 times f0 minus 3 times f0 plus f0 divided by 0. It is in the form of 0 by 0. Therefore, we apply the derivative concept. Numerator derivative is f dash of x minus 6 times f dash of x plus 4 times f dash of 4x. I hope it is 2x. F dash of 2x divided by 2x. Again, this is in the form of 0 by 0, 6 minus 6. Why don't you apply again the derivative? So when you apply the derivative here, 2 times f double dash of x minus 12 times f double dash of x plus 16 times f double dash of 4x. Of course, this is 2x divided by 2. And now when you substitute 0, 16 plus 2. Yeah, x equals 0 when you substitute 18 minus this one 6. So that is equals to 6 times f double dash of 0 by 2. So that is equals to 3 multiplied by 4. The answer is equals to 12 because f dash of 0 is equals to 4. So the answer is equals to 12. Coming to the next one. E power 1 by x minus 1 by e power 1 by x plus 1. And at x equals 0, we need to find. Since 1 by x is there, it is at point x equals 0, we need to proceed by taking the limit values LHL and RHL. We know e power 1 by x minus 1 by e power 1 by x plus 1. Okay, as x approaching to 0 minus from the left side, so 1 by x approaches to minus infinity. We know that. When 1 by x approaches to minus infinity, e power 1 by x approaches to e power minus infinity, definitely that is nothing but 0. Okay, therefore when I take up e power 1 by x minus 1 divided by e power 1 by x plus 1 and limit x approaches to 0 minus LHL, I am calculating it. So therefore the answer for this one, e power 1 by x equals 0 minus 1 by 0 plus 1, the answer is minus 1. Suppose x approaches to 0 plus, then 1 by x approaches to infinity, e power minus 1 by x approaches to e power minus infinity, that will be 0. So that the given problem extending to 0 plus, I shall take out to e power 1 by x common 1 minus e power minus 1 by x divided by e power 1 by x into 1 plus e power minus 1 by x. So that these two gets cancelled and e power minus 1 by x tends to 0 and that gives you 1 minus 0 by 1 plus 0, that is equals to 1, and this is RHL and this is LHL. And therefore I say LHL is not equals to RHL and therefore limit value does not exist. So therefore continuous, not continuous and not continuous and does not exist. So answer is equals to not continuous at x equals to 0 because limit does not exist. But the value is existing it. Coming to the next one. The value of b for which f is continuous. 5x minus 4, f is equals to 5x minus 4 when x is less than 1 and 4x square plus 3bx. 4x square plus 3bx when x is less than 1, x greater than 1. Yeah, greater than 1 and less than 2. And f is said to be, f is a function continuous at x equals to 1. Because it is continuous at x equals to 1 also continuous function. So therefore f of 1 minus is same as f of 1 plus. And that is written as 5. That implies 5 minus 4 x equals 1 substituting is equals to 4 plus 3b. So therefore 3b must be is equals to 5 minus 8 that equals to minus 3. So b is equals to minus 1. So the answer is equals to minus 1a. Coming to the next one. F of x is equals to ax minus b divided. Of course, this is a discontinuous at x equals to 2 and continuous at x equals to 1. So since it is continuous at x equals to 1, clearly this number is equals this number x equals to 1. That means when I substitute x equals to 1 here, a minus b must be is equals to x equals to 1, substituting in the 3x, you'll be getting 3. A minus b equals to 3, therefore a is equals to 3 plus b. A is equals to 3 plus b. At the same time, it is discontinuous at x equals to 2, means 2 substituting 6. So 3x value when I substitute here, 6 cannot be is equals to. And if I substitute x equals to 2, 4b minus a. So 4b minus a. And a value when you substitute 6 not equals to 4b minus a means minus 3 minus b. Therefore 3b cannot be equals to 9, b cannot be equals to 3. So the answer for the problem is equals to b is not equal to 3 and a is equals to 3 plus b is answered. Coming to next 41, f of x is equals to x to the power of 4. So clearly you could see that when you find the derivative, f dash of x will be is equals to x power 99. F dash of x will be is equals to x to the power of 99, x to the power of 98, x to the power of 97 and so on. Lastly, you'll be getting x derivative 1 plus 0. And you require to find the value at point x equals 0. Substituting 0, you'll be getting only 1. So the answer is equals to 1. Coming to the next one, 42. Secant inverse of x plus 1 by 1 minus y is equals to a. So why can't you take out the secant x common? Secant right side. You can write x plus 1 divided by 1 minus y is equals to secant a. So that x plus 1 is equals to secant a multiplied by 1 minus y, keeping secant a as a constant value. Now find the derivative both sides, x derivative 1 and that is equals to y derivative dy by dx minus 1 into secant a multiplied by dy by dx. So dy by dx is equals to, it is minus 1 by secant a. But secant a from here, I can directly substitute and you will be getting x plus 1 divided by y minus 1 would be the answer for the problem. X plus 1 divided by y minus 1. Dy by dx, is it reciprocal? Yes, I hope it's a reciprocal of this one. And that is equals to y minus 1 divided by x plus 1. Thank you. So it is, the answer is equals to y minus 1 by x plus 1. Coming to the next one, the function is find the value of f of 2 when the function is continuous. Means value of the function is equals to limit of the function 2 power x plus 2 minus 16. So f of 2 is equals to limit extending to 2. So 2 power x plus 2 means 4 times 2 power x minus 16 divided by. So 4 power x minus 16. 4 power x minus 16. I hope I can take out the common value, limit extending to 2. So 4 multiplied by 2 power x minus 2 square divided by, so 4 power x minus 4 square. Extends to 2. Yes, of course, this value happened to be 0 by 0 form. You can apply the derivatives concept. Therefore, numerator limit extending to 2, 4 multiplied by 2 power x into log 2 divided by 4 power x multiplied by log 4. Of course, log 4 can be replaced by 2 log 2. So that log 2 gets cancelled. As extending to 2, you'll be getting 4 multiplied by 4 and divided by 16 into 2. So that is equals to 1 by 2. So the answer is equals to 1 by 2. Coming to the next one, 44. Consider the function f of x is equals to x square by modulus of x. Clearly you could see that x by mod x. We know when I take up x divided by mod x is equals to, it is minus 1 when x is less than 0, plus 1 when x is greater than 0. And if I take up x square by mod x, this is x multiplied by x by modulus of x. So as extending to 0, the result of this one is equals to 0. So therefore, it is a continuous function. So therefore, I say it is a continuous everywhere. So therefore continuous everywhere. It's not continuous at 0 is wrong, and discontinuous everywhere is wrong, and continuous only at the point x equals 0, because for other values it's nothing but the polynomial function. Okay, so it is continuous everywhere. Coming to 45, f of x equals to x sine 1 by x when x is not equal to 0, then the value of the function at x equals 0 is how much? So quite easy one, x multiplied by limit extending to 0, x multiplied by sine 1 by x. See, as extends 0, 0 multiply by a finite value will always be equal 0. So the limit value is always 0. So what is the value of the function has to be is equals to 0. Value of the function has to be 0 because it is differentiable at the point 45. The answer is 0. Coming to the next 46. As extending to, yes, let's see that function is continuous everywhere. So at x equals to pi by 4 is also continuous. But when pi by 4, when you substitute, it is in the form of 0 by 0. So let me calculate the value of the function at point this one. So the value of the function, actually the question is supposed to be the value of the function find. So find value f of pi by 4, the value of the function at this point. We need to calculate. So let me check up this one. Tan pi by 4 minus x. Tan pi by 4 minus x divided by, so cot 2x. Cot 2x. And the limit extending to pi by 4. And as it is in the form of 0 by 0, I can apply the derivative concept, limit extending to pi by 4. Tan derivative is equal to secant square pi by 4 minus x, and x derivative minus 1 divided by cot derivative minus cosecant square 2x multiplied by 2. Of course, when x tends to pi by 4, this value happen to be 1 and this value is also 1. So minus minus cancellation will be getting 1 by 2. So the value of the function at pi by 4 is equals to 1 by 2 is answered. So you are asked to calculate f of pi by 4 in this problem, provided the function is continuous. Excuse me. Coming to the next one, limit extending to 3. X square minus 9 into x square plus 4 divided by 2x square minus 3x minus 9. X square minus 9 multiplied by x square plus 4 divided by 2x square minus 3x minus 9. 2x square minus 3x minus 9. Of course, as a limit value extending to 3. When I substitute 3 3s are 9, 18, 18, of course 0 by 0 form. 0 by 0 form. And definitely we can factorize the denominator, I hope so. X square minus 9 can be, x square minus 9 into x square plus 4 divided by, I hope we'll be getting 2x minus 3 multiplied by x minus 3 minus 6x and plus 3. So that one factor gets cancelled, remaining x plus 3. Now when you substitute x equals 3, 3 plus 3 is 6 multiplied by 9 plus 4 13 divided by 6 plus 3 9. Simplifying, this will be getting 26 by 3. So the answer is equal to 26 by 3. Coming here, the function is differentiable. Yeah, the function is derivable at x equals to 1, means the derivative of the function. Once the function is differentiable, definitely the function is continuous. So x equals to 1, if you substitute, a plus 1 equals a plus 1. So let us see that ax square plus 1, the function when x is greater than 1, and it is x plus a when x is less than or equals to 1. So therefore, as the function is differentiable, why can't you find the derivative of the first one? It is 2ax and this is 1. and therefore f dash of 1 minus is nothing but 1 itself. Supposed to be it is f dash of 1 plus, and that is equals to 2a. You substitute x is equals to 1, 2a. So 2a has to be is equals to 1, and therefore a has to be is equals to 1 by 2. So the answer for this one is nothing but a is equals to half. So when the function is differentiable, f dash of 1 minus same as f dash of 1 plus at x equals to 1. Coming here, the modulus x. Clearly you can see that the modulus x is no doubt continuous but not differentiable at x equals to 0. Okay. So therefore, f is differentiable for all x. I think first option is wrong, I think so. F is continuous everywhere. Yes, of course, it might be right. But when I take up at x equals to 1, left to 1 it is 0, right to 1 it is 0. F of 0, f of 1 plus, it is equal 0. F of 1 minus, I hope we'll be getting this is a 1 now. So therefore, it is f of 1 plus is not equals to f of 1 minus. So obviously, the function is not continuous at this one. Okay, and therefore, f is not differentiable at x equals 0. Clearly, you can see that at x equals minus 1. Yes, it is not continuous at, When I take up the differentiable, the function f of x is equals to, yes, it is 1 when x is less than or equals to minus 1, and is minus 1 when x lies between minus 1 and 0, and 0 to 1 it is plus 1, and 0 when x is greater than 1, greater than or equals to 1. Clearly you could see that the derivative of at this point minus 1, this is 0, and 0, this differentiable. So therefore, differentiable at minus 1. So the answer is equals to D. D na? Yeah, continuous at x equals to, no. The answer is C, differentiable at x equals 0, correct. Differentiable for all values, yes, of course. Differentiable for all x is not 0 because at point 0 when I take up. So at x equals 0, the derivative, yes, of course, it is 0, differentiable. At point 1, derivative is also equal. At point minus 1, it's not continuous. So therefore, it is not continuous. It is continuous at x equals to minus 1, discontinuous at point 1. I hope it is discontinuous at x equals to minus 1. Discontinuous at x equals to continuous because it is minus 1, this is a plus 1. Minus 1 plus 1. So it is supposed to be discontinuous at x equals to minus 1. Okay, right. Let me go for next one. The derivative of modulus x. Mod x is a function actually. The graph of the function looks like this one at x equals to 0. So therefore, f of x modulus x is equals to plus x if x is less than 0, greater than 0. And minus x if x is less than 0. The derivative of this one will be is equals to 1 and minus 1. Both of them are not equal at the point x equals 0. Therefore, it is not derivable at x equals 0. So the answer is none of these answers. Yes, none of these answers. So this is about the differentiability. Let's go for the problems on differentiation. A few problems let's work out. F of x is equals to sine inverse of 3 minus x by 3 minus 3 plus x. And secant inverse of 3 minus x by 3 plus x. What is the value of the derivative at this point? See, f of x is equals to sine inverse of 3 minus x. 3 minus x of this one. Can't you write this one as a cos inverse of this one? Sine inverse of 3 minus x by 3 plus x. Cos inverse of the same function. Get it? Sine inverse plus cos inverse x is pi by 2. Therefore, the derivative is equals to 0. So the answer is equals to 0. Yes. Coming to the next one. F of sine x is equals to tan square x. Then what is f dash of x? f of sine x is equals to, so tan square x. Tan square x can be written as 1 divided by cot square, and cot square can be written as I think it is cosecant square x minus 1. Cosecant square, and cosecant square is nothing but 1 by sine square x, and therefore it can be written as sine square x divided by 1 minus sine square x. So if I can replace sine square x as x divided by 1 minus x, x square divided by 1 minus x square. So now we would like to find the derivative of this function. So f dash of x is equals to 1 minus x square taken whole square, 1 minus x square multiplied by 2x minus x square multiplied by minus 2x. So I hope 2x cube gets cancelled, becoming 2x by 1 minus x square taken whole square will be the answer for the problem. So 2x divided by 1 minus x square whole square. Coming to the next one, y is equals to sine by cos square x. The answer is in terms of secant and tan. Why don't you convert in terms of tan? Sine by cos is a tan into secant. Y is equals to secant x multiplied by tan x plus 1 plus sine x by cos x, logarithm of secant x plus tan x. Logarithm of secant x plus tan x. Secant x plus tan x. Now dy by dx is equal to how much? Derivative of this one. Yes, the derivative dy by dx is equals to, and secant x multiplied by tan x derivative is secant square x, and secant x derivative is equal to secant x tan x. So you'll be getting secant x multiplied by tan square x. So plus derivative of secant x plus tan x is 1 divided by secant x plus tan x multiplied by secant x tan x plus secant square x. And this is nothing but it is a secant cube x plus secant x multiplied by tan square x plus 1 secant x. When you take out the common, this is nothing but secant x plus tan x. So that these two gets cancelled, be getting secant x. So from these two, when you take out the common value, you will be getting 1 secant x. 1 plus tan square is secant square, will be getting secant cube x. So 2 times of secant cube x. So the answer for the problem is equals to 2 times secant cube x. When you go with the next one, of course, I hope we finish the problem and the last, slides. Let's do it once again. Therefore, it is secant A can be written as x plus 1 by 1 minus x. Secant A is equals to x plus 1 divided by 1 minus y. So 1 minus y, we want to find dy by dx. 1 minus y multiplied by secant A constant value is equals to x plus 1. Derivative on both sides will be getting minus secant A into dy by dx is equals to 1. So therefore dy by dx is nothing but actually it is minus 1 divided by secant A. So why didn't you substitute secant A reciprocal here, which is nothing but actually x plus 1 by 1 minus y, which is same as y minus 1 by x plus 1. Answer is equals to y minus 1 divided by x plus 1. Coming to the next one, the differential coefficient of f of sine x is equals to f of sine x. F of sine x where sine x with respect to x, where f of x is equals to like log x. F of log x. So clearly you can see that f of x is log x. So therefore definitely f of sine x will be is equals to logarithm of sine x. I want the derivative of this function is nothing but actually derivative of sine x with respect to x is nothing but 1 divided by sine x. Sine x derivative is cos x. So the differential coefficient of f of sine x only, but not f of x. So you can take it as this one as directly cot x. So the answer is equals to cot x problem. Coming here, the sixth one, y is equals to sine x divided by tan x. So 1 plus tan x. I hope it is a direct answer for the problem. Signed by cos 1 plus tan x. There it is simplification. Sin x. Y is equals to sin x divided by 1 plus tan x. The derivative of this on dy by dx is equals to 1 plus tan x taken whole square. So 1 plus tan x multiplied by sin x derivative is a cos x minus sin x multiplied by 1 plus tan x derivative secant square x. Secant square x. And secant square x can be replaced by 1 plus tan square x. 1 plus tan square x. And when you simplify this one, that is equals to, it is cos x and plus sin x minus sin x minus sin x into tan square x. Sin x multiplied by tan square x and divided by 1 plus tan x taken whole square. These two gets cancelled, cos x minus sin x, and therefore why don't you take up the common value, because this one sin cube x divided by cos x. Simplifying, you will be getting answer is equals to C. Cos x multiplied by 1 minus tan cube x divided by 1 minus sin x. Coming by next one. Y is equals to logarithm of e power x by x square. So y is equals to log of e power x by x square is nothing but x minus 2 log x. Clearly y dash is equals to 1 minus 2 by x. I hope it's simple problem. 1 minus 2 by x. Coming to 8th one. F of x equals to x minus x square plus x cube minus x to the power of 4 and so on up to infinity. Yes, of course. And why don't you rewrite this one as 1 minus of 1 minus x plus x square minus x cube plus and so on. I'm adding and subtracting 1 so that this is nothing but 1 plus x taken whole to the power of minus 1. And therefore derivative of this one is equals to 1 derivative 0 minus 1 into minus 1 1 plus x to the power of minus 2. So answer is equals to 1 by 1 plus x taken whole square. 1 by 1 plus x taken whole square of this one. Coming to the next one. Y is equals to, clearly could see that this is e power x. And therefore e power x derivative e power x and therefore y only answer. So therefore y is equals to, this is y is equals to e power x and the derivative of y is equals to e power x. Derivative of e power x is nothing but y dash is equals to e power x, that is nothing but y itself. So the answer is equals to C. Coming to the 10th one. F of x is x to the power of m, then find a positive integer m such that f dash of alpha plus beta is equals to f dash of alpha, f dash of beta. So I say f of x is equals to x to the power of m. F dash of x is equals to m x to the power of m minus 1. F dash of alpha plus beta is equals to f dash of alpha plus f dash of beta. Clearly by substituting, I hope we'll be getting alpha plus beta to the power of m minus 1, m multiplied by alpha to the power of m minus 1 and beta, it is m multiplied by beta to the power of m minus 1. And clearly m is equals to substitution, of course option wise you have 3, 1, 4, 2. I hope 1 does not satisfy the condition here, because 0 power will be getting alpha plus beta power 0, 1 is equals to 1 plus 1. Doesn't satisfy. M is equals to 2 exactly satisfy the condition that alpha plus beta is equals to alpha plus beta. So the answer m is equals to 2 is answered. Coming to the next one. F of x is equals to 2a minus x divided by 3x minus 2. And f is differentiable for all the value, discontinuous at x equals a, etc. Let me check up that the point x is equals to a, the derivative. So f of x equals to, it is 2a minus x and 3x minus 2a. So for the values of x greater than, yes, f dash is equals to, it is minus 1 and it is equals to 3. And both of them are not equal at the point x is equals to a. So therefore I say that the derivative at the point x is equals to a. When I take up f dash of a minus not equals to f dash of a plus. And therefore the function is not derivable at the point x is equals to a. The function is not differentiable at x equals to a. Coming to the next one. Y is equals to log mod x. It's a direct formula. 1 by x answer. So direct formula. Let's not work out much about this one. Answer is 1 by a. Sorry, 1 by x. Derivative of f inverse of x. X square minus x by x square plus 2x. X square minus x divided by x square plus 2x. So let me take up this one as x by taken x common, x minus 1 divided by x plus 2, provided the domain is nothing but r minus minus 2 comma 0. Now to calculate f inverse, we want to find the derivative of f inverse. Why don't you express x in terms of y? Xy plus 2y is equals to x minus 1. So x multiplied by y minus 1 is equals to minus 1 minus 2y. So that x is equals to 1 plus 2y divided by 1 minus y. So f inverse of x, and that is equals to, it is 1 plus 2x divided by 1 minus x. And the derivative of this f inverse of x will be is equals to 1 minus x taken whole square, 1 minus x multiplied by 2 minus of 1 plus 2x, 1 minus x derivative is plus 1. I hope you'll be getting 2x gets cancelled, 2 divided by 1 minus x taken whole square. So 1 minus x whole square. Coming to the next one. Y is equals to this function for different values of n, for n 1 plus x, 1 plus x, 1 plus x square, 1 plus x power 4 and so on, 1 plus x power 2n, then divide by dx at x equals 0. Because you have got the product of the numbers here, why don't you take logarithm here? Logarithm is equals to logarithm of 1 plus x plus logarithm of 1 plus x square plus and so on logarithm of 1 plus x to the power of 2n. Yes, of course, these are values. Divide by dx at x equals to 0. Let me calculate y value itself at x equals 0. When x equals 0, y is equals to how much? 1. When x equals 0, y is equals to 1. Now let's find the derivative on both sides. 1 by y dash is equals to 1 by 1 plus x plus 1 by 1 plus x multiplied by 2x plus 1 by 1 plus x to the power of 4, 1 by x square, and 4x cube plus and so on. In every other term, x is existing. So therefore, when you substitute x equals 0, all the terms will become 0. And this is 1. And therefore, and y value is equals to 1. Y dash is equals to 1. So therefore, the derivative of this function is equals to 1 when x equals to 0. Let me take up y is equals to modulus x, modulus of cos x plus modulus of sin x. So find the divide by dx at x is equals to 2 pi by 3. Let me evaluate this one. Y is equals to derivative at the point 2 pi by 3. Y is equals to modulus of cos x plus modulus of sin x. Derivative at the point 2 pi by 3. But at point 2 pi by 3, the value of sin x is a negative number. So in the second quadrant, it is cos is negative. So why don't you take up now at x is equals to, so 2 pi by 3, left to 2 pi by 3, right to 2 pi by 3. So y is equals to, it is minus cos x plus sin x, and the derivative of this one is equals to dy by dx equals to plus sin x, because minus cos x derivative minus sin x plus cos x. And therefore, x equals to 2 pi by 3 when I substitute cos 2 pi by 3 root 3 by 2 minus 1 by 2. So answer is equals to root 3 minus 1 by 2. So the answer is equals to, yes, root 3 minus 1 by 2. C answer. Coming to the next one, f of x equals to 2 plus x positive, 2 minus x negative. F is equals to 2 plus x when x is positive and 2 minus x when x is negative. Why don't you consider the derivative? 1 minus 1 when positive, when it is negative. Clearly, it is not differentiable at x equals to 0. It is not differentiable at x equals 0. Coming to y is equals to log of log sine x, then divided by dx is equals how much? So y is equals to logarithm of log sine x. So dy by dx is equals to 1 divided by logarithm of sine x into 1 divided by sine x into sine x derivative is cos x. So cot x divided by logarithm of sine x. So cot x by log of sine x. Coming to the next one, y is equals to 2 into under root of x plus. So why didn't you take out, 2 as a power, you'll be getting logarithm of x plus root of x square plus 9. Y is equals to 2 logarithm under root of x plus root of x square plus 9. And therefore, y is equals to logarithm of x plus root over x square plus 9. I hope you know this is nothing but the derivative of actually integral 1 divided by root of x square plus 9 dx is nothing but this value. Answer. So therefore, the derivative of this is nothing but a root. So therefore, dy by dx for this problem is 1 divided by root of x square plus 9. You could also remember integration formula. Integral of the answers will be easy if you are confident about integrals. Otherwise, you can do directly the derivatives here. Now, simple derivative of this one. So, y dash is equals to 1 divided by x plus root over x square plus 9 multiply by x derivative 1 plus 1 divided by 2 root 2x divided by 2 root of x square plus 9. So, that 2 gets cancelled, take an LCM 1 by root over x square plus 9 and it is x plus root of x square plus 9 divided by x root of x square plus 9. These two gets cancelled, results in 1 by root of x square plus 9. You can also direct calculations, you can do it. Next one, sine inverse x. Isn't it cos inverse x? So sine inverse x plus cos inverse x is equal to 0. So the answer is equals to, no need of any calculation, the answer is 0. Yes. So 20th one. Y is equals x tan x by 2, 1 plus cos x multiplied by dy by dx minus sin x. So y is equals to x multiplied by tan x by 2. So that you require to evaluate, you require to calculate, what do you call? 1 plus cos x into dy by dx is equals how much? So let me calculate what is the derivative. Dy by dx will be is equals to, it is a tan x by 2 plus x multiplied by secant square x by 2. And you are asked to calculate how much is the value of 1 plus cos x divided by dx minus sin x. 1 plus cos x into dy by dx minus sin x. So why don't you substitute this one here? So that will become actually secant square x 1 plus, it is 1 plus cos x. 1 plus cos x multiplied by, it is a tan x by 2 plus x multiplied by secant square x by 2 minus sin x. I hope this can be replaced by 2 cos square x by 2. So when you just multiply here, you will be getting 2 times 1 cos gets cancelled, will be getting sin x plus x multiplied by 2 times of this one, you will be getting x itself. Yes, this 2 gets cancelled and minus sin x. So the answer is, I think it is x by 2. Because sin square d by 2, derivative is equal to 1 by 2, you will be getting 1 by 2 gets cancelled, be getting sin x. So answer is x itself. So the answer is equals to x, D. Coming to the next one, y is equals to sine inverse root over 1 minus x. Of course, can I write this one as a cos inverse of root x? Yeah. and this also cos inverse root x by the formula. Therefore, this is nothing but sine inverse of under root of 1 minus root x whole square. So that is nothing but actually cos inverse of root x, 2 root of cos inverse x. So therefore, it is y is equals to 2 cos inverse of root x. Derivative dy by dx is equals to minus 2 divided by root of 1 minus x into 1 by 2 root x. So obviously minus 1 by x root x square, root x into 1 minus x. Coming here, x is equals to 3 cos theta plus sin theta. dy by dx is equals to parametric differentiation. So dy by dx is equals to dy by d theta, first one. So a multiply by 3 cos theta, a multiply by 3 cos theta plus 3 cos 3 times of cos 3 theta divided by, and cos will become minus sine, 3 sin theta plus minus a multiply by minus 3 sin theta minus 3 sin 3 theta. So minus 3, of course you can have a common 3a multiply by cos theta plus cos 3 theta and divided by minus 3a multiply by sin theta plus sin 3 theta. Using transformation formula, this is minus of cot average of angle 3 theta plus theta 4 theta by 2, nothing but 2 theta. So the answer is equals to minus cot 2 theta. So answer is D. Coming here, y is equals to theta cos 2 theta, x is equals to theta sin 2 theta. So the answer for the problem, y is equals to theta cos 2 theta. So dy by dx is equals to derivative of theta cos 2 theta. So d by d theta of theta cos 2 theta divided by d by d theta of theta sin 2 theta. So the derivative sin 2 theta, that is equals to, it is cos 2 theta minus 2 theta multiplied by sin 2 theta divided by, it is sin 2 theta plus 2 theta cos 2 theta. And thereby you substitute now the value theta is equals to pi by 2. When I substitute, pi by 4, sorry. It is pi by 4 when you substitute. This will become pi by 2 and this is a pi by 2. Sin pi by 2 1 and this is a pi by 2 and this value pi by 2. Cos pi by 2 will become 0. This will be 0. So therefore 0 minus pi by 4 will become pi by 2 divided by, will be getting 1. So answer is minus pi by 2. Answer is minus pi by 2. Coming to the next one, 24. X is equals to cos a times cos t plus logarithm of tan t by 2, y is equals to a sin t. So dy by dx. dy by dx is equals to derivative. So d by dt of a sin t divided by derivative of, so cos t plus log tan t by 2. Cos t plus log tan t by 2. So the derivative of this one is equals to a cos t divided by minus sin t plus derivative of logarithm of tan t by 2, 1 divided by tan t by 2 multiply by secant square t by 2 multiply by 1 by 2. Multiply by 1 by 2. Simplifying this one, that is equals to a cos t divided by, of course the denominator a will be there. So therefore a, I forgot to write. So a gets cancelled. A multiply by minus sin t plus, and this on simplification sin by cos, I think one cos gets cancelled. 1 divided by sin t, you get it. And that is equals to, you will be getting cos t multiplied by sin t divided by cos square t. So that one cos gets cancelled, the answer is equals to tan t. So the answer for the problem is equals to tan t. Coming here, 25th one. At point t is equals to 1, then dy by dx is equals to 1. How much is that? Let me calculate. dy by dx is equals to dy by dt, that's nothing but sine pi by 2, will become pi by 2 times cos pi by 2. So cos pi by 2 times of t, and pi by 2 times minus sine pi by 2 times of t divided by, and t square plus t plus 1 derivative 2t plus 1. 2t plus 1. And I need the value at the point t is equals to 1. T is equals to 1 when you substitute, it is pi by 2. This will become 0 minus 1 divided by, it is 3. So that answer is equals to minus pi by 6. So the answer is equals to minus pi by 6. So D is answer for the problem. Right? So in this video, we continue the remaining problems in the other